now we have one presentation of a poster. This is from Paul Andrei, and the poster is entitled Process to Examine Correlations Between Personality Traits and Architectural Aesthetics Preferences for Complexity. I know Paul well, and we've researched before together, and I believe Paul has an ambition to make this an application, right, Paul?
Yeah, that's true. Hello. Hi.
Hello.
It's great to be here.
Yes, so Paul, go ahead. Thank you for being here.
Okay, so good afternoon, everyone. My name is Paul Andrei Burghelea. I'm going to present today my poster named Process to Examine Correlations Between Personality Traits and Architectural Aesthetic Preferences for Complexity. This was started at the Bartlett School of Architecture as part of my thesis work. This process was created to aid an experiment in data analytics and psychology that I previously presented in the second session of the conference. It was used only once to discover correlations and trends within the aesthetic preferences of a small population sample, but it needs to be adjusted and researched more to find if it's usable in larger samples. This is still a work in progress process, and the long-term goal is to serve it as a way to quantify preferences for architectural aesthetics within a population sample. For this presentation, I split the process in stages to make the data path more organized and easier to track. This slide is what a normal data analysis process would look like. And this is how the current process can be used as. Because most of the variables and materials are preset, the ask and prepare stages are reduced, while we would recommend to act on the results with precaution, since this is still experimental. The development of the process started with asking the relevant question to help solve the difficulty to quantify how much personality influences our aesthetic preferences within architectural design. This is certainly extremely difficult to answer, if not impossible, but I choose to make the first step by tackling the smaller problem of complexity, asking how to quantify the aesthetic preferences for scene-constrained architectural complexity within a small population sample. For the prepare stage, I included data typology, collection methods, and target participants. The aim of the process is to compare the participants' aesthetic preferences for architectural scenes with their personality traits in order to observe trends in the data. The main used materials were a trait personality test and a series of photographs that were also converted to 2.5D images. I will explain this process more in the following slides. The process uses the Big Five model, a well-recognized model in psychology, and also the International Personality Pool, International Personality Item Pool, NEWA 120 questionnaire to collect the personality data. For the image material, I used 3 sets of 36 images containing exteriors, interiors, and surfaces that were part of specific buildings from Russia, Germany, United Kingdom, Hong Kong, Italy, Romania, and more. Those are some tables containing a small subset of each category. All images were scored and classified using computer vision scripts. This was done in order to create image ranking for complexity based on edge density. After, the images were classified and ordered in 2 sets using the initial ratings to ensure that the scenes were evenly distributed. A script was used to produce normal and depth maps, and with the use of 3JS, the images were projected in a 3D environment in order to give the participants the illusion of scale and depth. As I mentioned before, this process was previously used in one experiment. The experiment was split into 2 sessions and had a small sample of 10 participants. And this diagram shows the experiment timeline for each participant. The first session was longer, containing a general participant data form, an IPAP NEWA 120 personality test, followed by an image rating questionnaire with 54 images of building exteriors, interiors, and surfaces. The second session only contained another image rating formula with a different set of 54 images. Even though the sample size was small, there were 460 variables to collect from each participant. From each, 16 were general, such as age and nationality. 120 were the result of the personality test, and the rest of 324 were collected over the 2 aesthetic questionnaire sessions, where the participants rated the beauty, familiarity, and complexity for each photograph from the earlier described image sets. A custom software was built to collect the data from the participants. It was designed for ease of use and to seamlessly organize the data, preparing it for processing. At the end of each session, it exported the results in a JSON format. All this work was put in since I wanted to streamline the data analysis process with the aim of making it scalable for any potential future use. The software was built using web technologies, using Three.js, React, Node, and Electron to create a desktop application, while still having the option to deploy the application on a server, allowing it to be used in the browser. This diagram summarizes the process stage, shown in blue, and the analyze stage, shown in red. The green elements are part of the IPIP's personality assessment process. You can see the use of Pearson PCs, or Pearson correlations, RG, univariate regressions, data ordering, cleanup, transformation, and standardization. I will firstly talk about the process stage, containing the data cleanup, transformation, standardization, and ordering. So after the results from all participants were collected, they were reorganized using Microsoft Excel. The table on this slide contains the data from the image ratings of exterior, interiors, and surfaces. The raw participant complexity ratings were kept in the system as numbers from 1 to 10 and were converted into labels using a formula that takes into account the variety in each participant's answers. This means that for the final analysis, the subjectivity of the rating scale will be reduced. And this is a diagrammatic representation of the variable labeling model, having the aesthetic preferences split into exteriors, interiors, and surfaces with low, mid, and high complexities, and each of them containing a value for the participant rated familiarity and beauty. Those categories were used during the analysis stage by running a simulation for each combination in an attempt to find significant correlations within the data. One example of a valid simulation would be correlations for openness with low complexity exteriors, or correlation for actions with high complexity surfaces. After, the image labels were compared with the original edge density ratings for future improvements in the ordering process. This stage contains the data analysis. Here I use Pearson correlations and univariate regressions. So using Excel, I created a table to standardize the data within the collected sample, while the personality data was standardized within a UK population sample. Since there were many variables to go through, the data was firstly run through multiple Pearson correlations, which gave me the initial results. This operation was generated using IBM SPSS. This slide contains examples of the most interesting correlation results. And those are the plots of the findings from the experiment, divided by complexity groups. The red dots represent the participants from the control group, and the blue dots represent the participants from the experimental group. And the final stage of the process included an univariate regression. A cap was inserted, only analyzing the personality traits that had a p-value of below 0.01%. The final output is a table of univariate regressions that take into account the participant rated familiarity. The result from this particular sample was very optimistic, but as mentioned in the previous session, the curve of the conference, I consider them to be caused by the sampled population's high variability in personality traits. This is one of the reasons why a larger sample will be essential to research the usability of this process in the future. If developed more, the process has the capacity of producing some interesting metrics, but for now it's in the experimental stages. I made a few points that I want to address in the future. Since this process requires a substantial amount of work to be done manually, it will be extremely labor intensive if used in large samples. Most of the tasks can be automated, and I'm currently considering to switch the process fully to Python. Upgrades to the process, such as the use of neural networks to find patterns within the data, is also being considered. Participants' software user experience needs to be redesigned. And this process uses spreadsheet software to store the data. This was acceptable for the current stage, but to process and collect more data, SQL database needs to be implemented. And this is the end of my presentation. Thank you very much for listening, and looking forward to any questions.
Thank you very much, Paul.
Thank you very much.
Very interesting. Of course, early days, but very interesting that you're adding that that kind of sentiment analysis that could be used in things like a digital twin and other interfaces, yeah, or other platforms.